Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're looking at section 2 of chapter 4, and we're going to be exploring how to multiply polynomials together. Binomials meaning two terms. We're going to look at the distributive function, and then this last one is really important. If you're moving forward towards calculus, which some of you are, or even college algebra, you're going to need to know how to do this, which is a difficult process to do for functions. All right, so first of all, multiplying monomials, we learned the last video that monomials is one term. So this looks like maybe two terms because I have parentheses here, but monomials or terms are separated by addition and subtraction, so there's no addition or subtraction. So this is not two terms, this is just one term. And the neat thing about this is all we have to do is multiply the numbers together. So just pick out the numbers, which in this case is 1/2 and the 6, and just start multiplying. Half of 6 is 3. Then you pick out the x's. So I got an x cubed and an x term. And if you multiply those together, remember you rewrite the base and add the exponents. So that's x to the 4th. And likewise, y times y squared is y cubed. So we're just kind of rearranging these using the commutative property. It's 1/2 times 6 times the x's get multiplied together times the y's get multiplied together. So looking at our first example then, let's follow suit. 3 times 4 is 12. X squared, another x, is x cubed. And then let's just count. 7 plus 3 more y's give me y to the 10th. Final answer, 12y cubed. So I would skip all of this. This is nice work, but you don't need to show that to me. I think you can do that in your head. So remember, the distributive property says we're going to take a and multiply by both a times the b plus the a times the c. So the distributive property. So we're going to expand this a little bit and make the problems a little bit harder. This time we're not distributing just a coefficient or a number. We're going to distribute a whole monomial times a binomial, two terms. So this is your monomial, one term. This is times your binomial, two terms. But the process is the same. 2 times the 3 gives you 6. A squared times a to the 1st is a cubed. B to the 8th. So that's this times the first term. Now let's repeat this process and do this times the second. So 2 times the negative 6 gives me negative 12. A to the squared and squared gives me a to the 4th, and b to the 4th. Ooh. Did I have a 7 in there? I didn't even read that this was b to the 7th. I'm so sorry. So b to the 7th times b to the 3rd is b to the 10th. Yep. So again, if you wanted to show this step, you can, but I think, did we get a 12 here? Geez, yeah, 12. A to the 4th, b to the 10th. 12, a to the 4th, b to the 10th. So we're going to continue talking about how to, if you can't do a monomial times a binomial, this is a binomial times a trinomial. So but the process is the same. You take the 3g times all three terms, and then you go back and grab the negative 3 and multiply by all three terms. Multiply, stack, and add is sometimes what I call it. So I'm going to try this method. I'm going to start multiplying by distributing the 3x to every term. 3 times the 7, 21x cubed minus 6x squared plus 3x. So I distributed this 3x to every term. And this 3x times this negative 2x gives me the negative 6x squared. So now let's go back and grab the 2. So 2 times every term gives me, and I'm going to stack this. 2 times the 7 is 14. So I'm going to write this in green, 14x squared, and I'll stack it right with my other x squared terms. 2 times the negative 2 is negative 4x and plus 2. So that way I have like terms. I can just add down. 14 take away 6. Negative 4 plus 3. Final answer. Author agrees. They are actually showing a bunch of work here. And again, if you'd like to go through that and write all that out, knock your socks off. So product of two polynomials, again, you could just think about distributing. I wanted to show you could distribute backwards. Now you could take the 5x cubed and go to those two terms, but I think it's faster to distribute backwards. So I'm going to take this x squared and distribute over here. So I'll get 5x to the, remember it's rewrite the base and add the exponents, so be careful here. This is x to the 5th. Don't get that confused with x cubed squared, which is x to the 6th. So I'm going to add the exponents for a 5 plus x to the 4th plus 4x squared. I'm going to go back and distribute the 3x to every term. And I'm going to stack. So 3x times the 5x cubed gives me 15x to the 4th plus, now this is interesting, this is 3x times x squared gives me a 3x cubed, which I should have had right here. This should have been a 3, because this was a squared to the first. So back to this one, this is a 3x cubed plus 12, oops, apologize, x squared. Oh, let's add 5x to the 5th plus 16x to the 4th, 7x cubed, and 12x squared. Let's see if the author agrees, because I kind of bouched that a little bit. I think that's good. 5, 16, 7, is that what I had? Sounds good. All right, so again, there's something called the FOIL method, but the FOIL method only works when I have a binomial times a binomial. So you could do the first terms are the a, c, the outer terms are the a and the d, the inner terms are the b and the c, and then the last terms are physically the last terms in the parentheses. You multiply those together and get BD, and it's called the FOIL method. So if we have a binomial times a binomial, we can try it. First terms, x squared. Outer terms, notice this is nothing more than the distributive property. I took x times the first, x times the second, and then I go back and grab the negative 4. So instead of foiling, we could just continue talking about distributing. And I'll continue stacking. So I've got like terms that I can add. X squared plus 2x minus 24. So if you don't want to remember the FOIL method, then just keep remembering what we were doing before by distributing. So there's first, outer, inner, last, and oftentimes you can combine those OI terms, if you will, O and I, if it's pronounced OI. You get a little bit more difficult. First terms is 15x squared. Outer is 24xy. I can't multiply those together. 5xy. Now it doesn't matter if you say yx or xy, but I'm going to put it xy so you can see that I can combine those OI terms again. And then the last is 8y squared. So again, combining these terms right here, I'll get a 29. So 15x squared plus 29xy's plus 8y squared. Looks like the author agrees. A little bit more difficult. The danger here is students always want to try to distribute, so be careful here what not to do. If I have a quantity that's being squared, you cannot say that that's a squared plus b squared. In fact, there's a rule. You square the first, it's twice the product of the bases, and then square the last. So I'll give you some examples. So square the first, m squared, twice this product. Well, m times 7 is 7m, and then you double it. So you just multiply those numbers together, double it, twice 7 is 14, and then you square the last. So if you can remember the rule, square the first, twice the product, square the last, you're done. But if you don't want to do the rule, you could always write this out, m plus 7 times m plus 7, and do the FOIL method or just distribute. M times m is m squared, the outer is 7m, the inner is 7m, and then the last is 49. But you can see it's just a little bit longer process. You can get there faster if you know the rule, which is, again, square the first, twice the product, square the last. So I'm going to keep trying to use the rule because I think it's a lot faster. Here the author is trying to emphasize twice the product of those bases works well. So let's try it again. Square the first, which means 2x times 2x, which is 4x squared. And then it's going to be twice this product. Well, 2 times 3 is 6, and then I'm going to double it. Actually, this is 2 times negative 3 is negative 6. I'll double it. Negative 12. X squared, y squared, if I multiply those bases together. And then I'll square the last. Negative 3 times negative 3 is positive 9. x squared y to the fourth. So squaring the first, twice the product, well, the product of 2x and negative 3xy squared is negative 6x squared y squared. But then remember, you have to do twice that, and that's how I got the negative 12. And I think the author agrees. So this is called the difference of two squares. Oftentimes the most common example of difference of two squares is x squared minus 9. And the difference of two squares you can write as x plus 3 and x minus 3. So if it's a difference, notice that the outer and the inner terms will drop out, and you're really just left with the first and the last terms. So let's try it. The first terms is going to be y squared. The outer is negative 8y. The inner is a positive 8y. That drops out, minus 64. So if you multiply this together, it gives you y squared minus 64, and in later sections we're actually going to be going backwards. So this is called multiplying. Sometimes I start with this and I'll ask you to factor, and that's a later section, and you can watch a later video on that, factoring difference of two squares. So putting this together, first terms is 9m squared n squared. The outer and inner will cancel because it's the exact same thing. It's just this one's a plus and this one's a minus. It's called the conjugate, but you don't even need to know that minus x to the fourth. So that's easy to multiply it together. A little bit harder to factor, but we'll get it. So here's that last thing that I told you was going to be a little bit more difficult. F of x plus h, it has to do with calculus, finding the limit. So let's find this yellow first. It says every time, well, let's do something easier. If I were to ask for f at 5, that would say go to the f function, and every time you see an x, plug in a 5. So you do 5 squared plus 3 times 5 plus 2, and then you would number crunch that and get some kind of a number. So this says every time I see an x, this says plug in. So my recommendation would be rewrite x squared plus 3x plus 2, rewrite that with parentheses. Because every time you see this x in parentheses, you're going to replace x not with a 5 this time, but this time you're going to replace it with whatever it tells me. And in this case, it says a plus h and a plus h. And then you're not done, because remember, we can't distribute this, but I could square this out. Square the first, twice the product, square the last, distribute the 3, 3a plus 3h plus 2, and then try to combine some like terms. So, oh my gosh, I don't have a whole lot of like terms here. I'm looking. I don't think I have any like terms to combine. I wonder if that's just the final answer. Looks like it. Good. So this one's a little bit harder, because after I find f of a plus h, I have to subtract off f of a. So I think we just found f of a plus h. Ooh, I got to rewrite all that. I wonder if I can cheat. Oh, I could almost grab it. Ah, I think I did. So let's see. This is edit, and very hard to do. Paste. Alright, so there's my f of a plus h. So now I'm just going to subtract off, same answer as I had before, I'm going to subtract off the f of a, which is x squared plus 3x plus 2. But of course, that's, if I distribute that, that's like negative x squared minus 3x minus 2, if I properly distribute that negative throughout. And then, looking, well, no, it should be f of a. I'm so sorry. So this is an a, this is an a, this is an a term, this is an a term. So then looking to combine like terms, it looks like, I'm sorry, it's a mess, but this a squared looks like it could cancel with this a squared, because this is a positive, this is a negative, so the yellow is gone. And the negative 3a should cancel with the positive 3a. Oh, and one more. The positive 2 cancels with the negative 2. So the yellow, the blue, and the pink are all gone. And I think I'm just left with 2ah plus h squared plus 3h for final answer. 2ah, yep, there it is. A little bit difficult. So again, if you're just going to plug in a p plus 1, this would be 5 parentheses plus parentheses squared, and then in the parentheses, you put the p plus 1. So again, I think the key here is to replace x with just parentheses. So rewrite this whole statement, but instead of saying 5x, write 5 parentheses. And then in the parentheses, you put anything that they say to put. In this case, we're going to put p plus 1. Remember, you don't leave this, though. Let's try to simplify it. 5p plus 5 plus square the first, twice the product, square the last. And then I'll put the highest term first. So I'll start with p squared. I'm going to combine the like terms for a total of 7 p's and plus 6. And then this one, I'll just do this example right here again. Well, it's the exact same thing that I just had before, right? 5x plus x squared, same problem. So it's going to be this answer, which was p squared plus 7p plus 6. That's my f of, so that's the first part. Here in pink is all of this. But now I need to subtract off the f of a. And the f of a is this function, so 5x plus x squared. So this really becomes p squared plus 7p plus 6 minus 5x minus x squared if I properly distribute. And then combining like terms, oh shoot, this should have been f of a plus h. So this is an a and a. I got my letters mixed up again. And this is f of a. So I should have all a's, I think, in here. A. And that is a little bit more helpful because I couldn't subtract before. But I think these pink terms are gone, my a terms. Oh, and I think I can combine. I think this is 7a, take away 5a for a whopping, get a pen going here, 2a plus 6. Let's call that good. If you have questions, please feel free to email me.